Hi guys, welcome back to the channel. In this video we are going to discuss the half subtractor and full subtractor. So these two concepts are under the concept of combinational circuits. So let's get started with the half subtractor. So this is the half subtractor block diagram. So block diagram is nothing but a simple representation. So the logic block that inside we don't know what is that. So now we are going to explore that. So but this is the overall overview of the block diagram of half subtractor. So two inputs are going, we are getting difference and borrow. So the name itself suggests that half subtractor means itself it is the logic that is going to subtract and it will produce difference and borrow. For combinational circuit, truth table is very important. So let's first see the truth table of half subtractor. So this is the simple truth table of the half subtractor of two variables, that is a and b. So if you observe, for two variables we are going to have four combinations 0 0 0 1 1 0 and 1 1. So the difference is basically nothing but the difference. So in normal math we are doing like normal subtraction, but this is not normal subtraction, this is binary subtraction. So if you want to know more about binary subtraction, I am giving the video in the description, check it out. So let's have a quick overview of subtraction. What is the subtraction? So if you subtract 0 minus 0, we will get 0. 0 minus 1, in normal math we will take borrow. See, here also we are going to take borrow. So after taking borrow it becomes 2. So 2 minus 1, that is 1. So 1 minus 0, 1, 1 minus 1, that is 0. See, according to that I am filling in the table itself. So first one is 0 0, so that is difference is 0, borrow is 0. So second column is 0 minus 1, so subtraction is not possible, so we are going to take borrow. So in the borrow column we are going to put 1, and difference after subtracting 2 minus 1 we are going to have 1. So 1 minus 0 is 1, borrow is nothing, 0. So 1 minus 1 is 0, borrow is also 0. So this is a simple truth table of half subtractor. The truth table we have column called difference and borrow. So for the difference, the main thing we are going to find in this video is the difference formula or the output expression. For the borrow also we are going to see. So first let's start with the difference, the output equation. So for that we are going to highlight the ones where there is ones, we have to highlight them, and we have to write in the SOP format. So we have min terms in the places of m1 and m2. So according to that we have to write in the SOP form. So the difference equation would be a bar b plus ab bar. So that is the equation of XOR output. So we can simply represent that d is equals to a XOR b. Next column we have borrow column. So in the borrow also we should have the output expression. For that, in the one position only we have one min term, that is the m1 position. So according to that is a bar b. So the output of borrow is a bar b. It is somewhat similar to the half adder and half subtractor. So if you want the video of half adder and half subtractor, I am giving the video in the description, check it out. From the truth table we have extracted the output expressions for the difference and borrow. So the next step we are going to see is that how to formulate or how to create the circuit diagram from the output expression. So we already know the output expression for the XOR gate is simple XOR gate. So the next one is borrow. So borrow is nothing but a bar b. So we have AND gate. So AND gate will multiply both of them. So that is the simple output, I can say. So take the inputs of a bar and b, multiply with them with the help of AND gate. Now if you observe the circuit diagram and the block diagram, you can observe and notice one thing. That is, in the block diagram we have a, b as inputs, difference and borrow as outputs. So in the circuit diagram also I have highlighted with the box. That is, we have inputs a and b, and we are going outputs as difference and borrow. So this represents whatever may be the logic circuit present inside the thing, the box. So simply we are going to represent the full circuit as the block diagram. So that's the main representation of main usage of representing in the block diagram. Instead of representing all gates, we can simply represent in blocks, that is known as block diagram. Now let's discuss what is the main important of the full subtractor. So up to now we have the half subtractor. So half subtractor can basically do the thing that is subtraction. So it can perform subtraction between only two binary digits. It cannot perform between three binary digits. So now we can get it out. So subtraction can be performed in between only two decimal or two digits. It cannot be performed between three digits. Then why you are saying that? 3 means not directly in the sense 3. So if you observe directly here, there 0 minus 1, that is output is or difference is 1 and borrow is 1. Then we need to subtract that 1 minus 1. Then the difference getting there has to be subtracted from that 0. So that is our final output. So let's quickly see the full subtractor, and with the help of truth table we can understand how to subtract 3 binary digits at a time with the help of full subtractor. Remember this thing, we cannot subtract 3 digits or 3 binary digits with the help of half subtractor. We can only do with the help of full subtractor. So now let's see this thing. So suppose we have two half subtractors, so we cannot perform the borrow thing. The borrow first one cannot be subtracted directly at a single half subtractor, so we have to use the full subtractor. Let's see how that looks like. If you observe clearly, this is the block diagram half full subtractor. So we will be going to see the inside logic also now with the help of truth table. So let's see what is meant by that. So we are going to pass three inputs, A, B and borrow B in. The previous borrow this is. So we are going to have outputs as difference and borrow B out. So see clearly that we have passing three inputs, that is A, B, borrow. So first it will subtract A minus B, then the difference will be subtracted from the borrow. So that is the final output that we are going to have in the difference. If any borrow left over, that is the remaining borrow. That is the main thing we are going to see at a time, three input subtraction in full subtractor. So this is the truth table of three variables, that is A, B and Bn. So now we are going to fill from 0 to 7, that is 8 variable. 8 means 8 terms, we can say, for 3 variable, 2 power 3, 8. So we know how to fill that from 0 to 111, from 000 to 111. So now we are going to obtain the difference and borrow. So let's see quick examples. So if you consider the first one, that is 0 0 0, in the row wise, that is A, B, Bn, we have 0 0 0. How to subtract, I will say a simple example. So first you have to subtract A minus B. So you are going to get difference, that is 0. The difference you are going to subtract from B in, that is again 0 only. So I hope you understand the borrow and the difference both are zeros for the first row. So if you observe the 1, that is 0 0 1, you are going to subtract 0 from 0. We are going to get 0 output. So next we are going to subtract the difference of that previous one with the next B in, that is 0 only. 0 minus 1, that is 1. So the borrow is 1 and difference is 1, that is 1 1. For more clarity, we are going to see next two examples, that is 2 and 3. So 2 is 0 1 0. So we are going to subtract A and B. So that is 0 and 1. So after subtracting that, we have left with 1 and borrow is 1. So next we are going to subtract the difference, that is 1 minus next to Bn, that is 1 minus 0, that is output is 1, and borrow is left over borrow only, that is 1 only. So the output is output means difference is 1 and borrow is 1 for that. So if we observe 3, the next one, so in the 3, that is 0 1 1. So we are going to subtract 0 minus 1, that is A and B. So output is 1 and difference is 1, borrow is 1. So we are going to separate again difference from B in, that is 1 minus 1, that is 0, and borrow is 1. I hope you are understanding these things. So you can do remaining all things like that only. So let's see the last one, that is 1 1 1, so that you can understand more clearly. So we observe that we are going to subtract 1 minus 1, that is A and B. We already saw in the column also, column wise and row wise. So after subtracting that, we are going to get 0. Again we are going to subtract the difference from the B in. So the difference is 0. So 0 minus 1, that is 1. So and borrow will also be 1. So the output means the difference is 1, borrow is 1. So fill the remaining things as according to this and fill the table. So as we obtain the difference and borrow in the half subtractor, we are going to apply the same method in this full subtractor also. We are going to highlight all the min terms in this, that is M1, M2, M4 and M7. So according to the SOP format, we are going to write as product SOP, that is sum of product. So if you observe the terms is A bar, B in, A bar, B in, A B bar, B in bar and AB, B in. So this is the thing. This is somewhat similar to the half adder and half subtractor also. So you are going to take out the common A bar in first two terms and A in second two terms. If you observe clearly, the first term I have highlighted in black, that is known as the XOR gate. So the second highlighted one is, that is XNOR gate. So XNOR gate can be represented as XOR whole bar. So you can observe there, the two black terms are same, and for the second term take whole bar, that's it. So that is represented with the help of X. X means B XOR B in. So that can be simply represented as the difference is A XOR B in. I hope you are understanding this. The same fashion, we are also going to obtain the borrow. So for the borrow, we have two methods to be obtained. So two methods have their two purposes. So let's see the two methods. So first, let's see according to the normal Boolean expressions like Boolean minimization. So if we consider, we have four terms, four min terms. So that is m1, m2, m3, and last one m7. So we are going to obtain the SOP output format, that is that. So in the two terms, the second term and third term, we are going to have the common thing, that is a bar b. So after that we are going to have b in plus b in bar, that is 1 in Boolean algebra, according to Boolean algebra. So from the first and fourth term we are going to have the common things, that is b in. So in the inside term, that is a XNOR gate I can say, a XNOR b. So you can observe that clearly, b is, that is gone, that is b plus b bar, that is gone. So finally we have left with b is equals to a bar b plus b in a XNOR b. I hope you are understanding this borrow term also. For the borrow, we have the representation with the help of K-map also. So place all the four min terms in in the four positions. We have to place all the ones, and we have to make groups. So I hope you know how to use the K-map. So after filling that, I have made groups. So each group I have obtained the output expressions, that is the thing. So from this I can get the b out as a bar b plus a bar b in plus b in. So I hope you know how to draw or how to group them. If you don't know, I am giving the video in the description. Check it out how to use K-maps. Now we can get a doubt that for the difference we have only one output expression. For the borrow, why we have two output expressions for the borrow? So let's observe the first thing, that is the main important thing that we are going to use everywhere. So we already have the XOR, or we can convert into XNOR by inverting it. So that we are going to use the first representation for the circuitry representation. Because for that the circuitry is very minimum, and if lag of cost, we can use the first one. The second one requires more gates, so the representation is easy. It is very easy to by heart or very easy to remember. It is somewhat similar to the half adder and full adder. So that is a bar b, a b bar, and b in. So in the full adder, that is a b, b c, c a. So you can simply remember this also. So let's see their own uses. So let's see their circuitry diagram individually, so that you can understand which one is more important. The first one is more important. Let's see the circuit diagrams for the both equations. So let's start the circuit diagram for the full subtractor. So according to the difference formula, we are going to XOR with the help of two XOR gates. The first XOR gate will produce a XOR b. So after that, the output is again passed to the another XOR gate with the another input is b in. So the final output we are going to get is a XOR b in. So this is the simple difference formula that we can observe, that we can simply get from with the help of two XOR gates. Next main thing we are going to obtain in this is, with the help of first formula of the borrow, we are going to construct the circuit diagram. So if you observe, the formula is a bar b plus b in a XNOR b. So if you observe, we have already a XOR b, just invert it. So there we can observe we have two product terms, that is a bar b. So second one is b into a XNOR b. So for the first product term and the second product term, we are going to have two AND gates. So the first product term needs, that is a bar b. So already we have a b, just invert a, that becomes a bar. So a bar into b we can obtain simply. So the second product term is b in a XNOR b. So we can also obtain the simple b in, because it's also there in the second XOR gate. So simply take the b into the AND gate. The second input is a XNOR b. Already we have a XOR b, take the NOT gate. So that is the product term that we are obtaining. Add both of them with the help of OR gate, that is the final output. Both the inputs are same, means both the output expressions are same, so that the output expression I am writing in this format. If you have any doubt according to the two borrow output expressions, you can put all the variables a, b in the expression. According to the truth table, you can obtain the borrow expressions, means borrow in the digital format, and you can cross verify both of the output expressions for the borrow. So this is the second diagram for the borrow output expression according to the K-map. You can observe there according to the formula, that is a bar b plus a bar b in plus b in. According to that, I have formulated a circuit. So looking, this is somewhat hard, not it's hard, it is easy. How I will explain now. So according to the inputs, there are three variables that I am taking in the lines itself, that is a, b in. We have three variables, so I am taking three lines. So for the first XOR gate, I need two variables, so that is A and B, so I took that. So for the second XOR gate, I need the B in, so B in I took. So for the first AND gate, that is output should be A bar B, so according to that I have take the A bar and B. So the next one is B in, according to that I have to draw two lines. So the third one is B in, according to that I took. So where I need the requirement, I will draw the lines to there. So that is the simple representation. If you observe that we have extra one AND gate, so this is why we are not going to use. Wherever you see the main logic diagram or the circuit diagram is used this only. In the laboratories, records, or in the experiments also we are going to use this only. Often we are going to use that also. That is not big tough task to produce that circuit also, because any output, any circuit expression can be formulated with the help of the only output expression. So I hope you can formulate the circuit diagram with the help of the formula itself. So mainly use the circuit for all these things. Forgot to mention a small thing, that if you observe there in the block diagram and the circuit diagram, you can observe one thing, that the box I am highlighted, that is the half subtractor. You can clearly observe the half subtractor. Go back and once observe that half subtractor is the same thing that I have highlighted in the box. So full subtractor can also be implemented with the help of two half subtractors and one OR gate. So let's also see how to do that with the help of block diagram, and it's very simple. So this is the full subtractor block diagram. So we are going to obtain this only with the help of two half subtractors and one OR gate. So let's start. Take two half subtractors, and according to the two block diagrams, I am going to merge both of them and add OR gate, so that I can obtain the full subtractor with the help of two half subtractors. You can see clearly over there I have cascaded two half subtractors according to the circuit diagram. So I have obtained the borrow A bar B from the first one. Second one is A XOR B and B in. So I have added with the help of OR gate. So I have passed the output, that is difference, to the second half adder, means half subtractor. The final difference I am getting, and the borrow I am getting from the OR gate. So this is the block diagram of full subtractor by using with the help of the full subtractor can be represented in that fashion and this fashion, both are correct. Thanks for watching up to now.